via LoRec, and this is Maren Kopfeld. And this session is quite mixed and interesting variety of presentations on planetary boundaries and the energy climate change material nexus. So a lot to learn for everyone, I would guess. I'm not expert in all of those things, and I suppose no one is expert in all of those things. So you for sure take something home on the way from the next 1.5 hours. You may have seen that there are only 5 presenters in this 1.5 hours, and we like to share it evenly, not to give 2 presenters 45 minutes and 2 presenters, 3 presenters the same time, but to arrange it a little bit. Maren. I thank Maren because she jumped in to 2 guys who on short notice dropped out, and Maren said, oh yes, that's fine.
Yeah, so women taking the responsibility once more. No, I'm kidding. So as you can see, I'm not Fritz. I guess he's sorry he can't be here, but as I wanted to attend this session anyway, and Sylvia approached us yesterday that her co-chair went missing. I'm happy to take up the slack. Just like Sylvia, I might be a little bit of an expert in alternate things, sustainability, sufficiency, business models. Surely not all of those topics, but I'm really happy to be here and learn and improve my session sharing performance from yesterday even further. So thanks, Sylvia, for the trust.
So we start with the... Do we? Oh no, the wrong direction. Sorry. We start the first session with Hauke Schlesier, which is from EMPA, which might familiar to you, working on the Swiss level and beyond. And he is asking, is a good life for all possible within planetary boundaries? And he has a closer eye on measuring it through the donut. And the second speaker will be Roland Weber. And he is going to bring a win-win argument for sufficiency, because reducing consumption within sustainability boundaries also means reducing chemical exposure. So the floor is yours, guys.
Yes, welcome everyone. My name is Hauke Schlesier, and by now you have probably heard of the term donut multiple times in this conference. But what has not been addressed is whether it's actually possible to provide a good life for everyone within planetary boundaries. And if you look at the previous literature, we see that currently no country in the world is achieving the donut. You can see here in this figure the social performance of countries on the y-axis and the ecological performance on the x-axis. And in order to achieve a donut, all the countries would need to move to the upper left. But no country currently satisfies this constraint, these target, and they're all far away from the donut, as you can see. And not only that, you can see here the lines that within this chart that indicates the trend of countries over time. And you would see that countries are actually exceeding ecological limits faster than they're making social progress. So they're not even going into the right direction. And if you look at other studies that investigate scenarios that entail even very ambitious scenarios of climate mitigation and social policies, even they only come close to a donut in 2050 when they project into the future. So the question remains then, is it even possible to achieve a donut given our technological capacities and our current or projected population size? And this is the question of our study that we performed. And the way we want to tackle that question is by performing a life cycle analysis on decent living standards. So we started by actually collecting material and energy requirements for decent living standards in the foreground system, starting with nutrition, shelter, healthcare, education, and so on, and selecting the thresholds for these requirements for a decent living standards. And as you can imagine, it is very hard to pinpoint exactly the thresholds for decent living. And that's why, in order to reflect the possible values in the literature, we defined multiple demand scenarios here. And this defines then our basket of sufficiency. And this basket of sufficiency per capita is then provided by different provisioning systems, which are defined in our background system. And also we take multiple scenarios into account, starting as a default with a mainly fossil-dominated world that we are currently in, but also trying to test a scenario in which we would completely defossilize our provisioning system, replacing all the fossil inputs with renewables. And then in a third scenario, supply scenario, we would also remove all historical land transformations in our background system in order to be consistent with the steady state approach, where we essentially assume that we would eventually, as humanity, converge to a state and where we would not convert any more land to cropland. And then we perform the life cycle impact assessment, multiply the per capita impact with the population that we're projecting, and then benchmark the impacts against 7 planetary boundaries that are reflected by 11 indicators. So this is the method. Let's move to the results, actually. You can see here in this chart, the planetary boundaries in green, and the red line indicates the lower thresholds for these planetary boundaries. So in order to achieve a donut, all these impacts would need to be below the red line. And you can see in blue, the impacts of humanity in 2011. And as you can see, we're then transgressing the thresholds for 6 indicators, so not sustainable. So let's test the first scenario in which we would move to sufficiency for everyone, for more than 10 billion people, indicate here in red, without changing our provisioning system. In this case, we would make great progress on reducing our impacts on planetary boundaries. We would even achieve to be within the safe limit for land use. However, we would still transgress multiple thresholds here. So this is not sufficient to arrive at the donut. So let's transform our provisioning system towards a fossil-free world and see the effect on that. Here you can see that we would significantly reduce our impacts. We would even achieve to be within the safe limits for global warming potential. However, we would still transgress the nitrogen boundary, the biodiversity boundary, and the CO2 limit. So this is not sufficient. And if we would take a closer look at these results, we would see that most of the remaining emissions actually come from agricultural processes, more specifically by meat production. So let's test a low demand scenario which includes an essentially vegan diet for everyone. And there you would see that we could actually achieve to be also within the safe limits of nitrogen, but we would still transgress CO2 boundary and the biodiversity boundary with some percent, with some probability. But in this case, we would still take into account historical land allocation, which is inconsistent with our steady state assumption. So let's test a last scenario, and we would actually converge to a net zero land conversion. And in this case, you would see that we could provide a decent living standard for more than 10 billion people with a probability of 71% and staying within all the planetary boundaries. However, it is necessary for that to be completely free in our provisioning system, and also have a low demand, no meat consumption, or essentially no meat consumption, and also no land conversion. So in this case, we would actually achieve to provide a decent living standards for everyone. Let's conclude. Fulfilling the basic needs is technically possible for more than 10 billion people. I think this could be considered good news with high confidence even. We're speaking of 71%, which is more than the probabilities that are usually debated in climate debate, like 50%. However, there's no ecological space for luxury. At least we could not find one. So the donut, the access to the donut is still limited by the boundaries for CO2, biodiversity, and biochemical flows. However, we know where these are coming from, the remaining impacts, still mainly by agriculture. So in order, if we would improve our agricultural practices, then this may allow us to actually expand into the donut. And let us also move to some limitations of this study. First and foremost, we only modeled material needs. So immaterial needs like mental health, meaningful relationships, and so on are very hard to model in regard to their physical requirements, right? So you could argue that they don't need physical requirements. However, this is outside the scope of our study. Also, we didn't include material circularity and also no technological learning, taking a rather conservative approach when it comes to our technical capabilities. So I think we could even be more optimistic if we would model that. Also, since we're taking a steady state approach, that doesn't mean that transitioning into this state is actually possible. There could still be political constraints, social constraints, or sustainability constraints to that. So this is a limit to our study. And also, phosphorus flows are actually underestimated in our background system. So we will take a closer look at that to make sure that we would also be within the safe limits for phosphorus. I want to end my presentation here. And I think we have 2 minutes for questions, right? All right. Yeah.
Hi, your model doesn't take into account cultural dimensions, because in my country, if I didn't have food, some neighbor or somebody in the community is going to bring. We have barter systems. We do things voluntary and in kind. And those are what allows us to survive and have well-being.
Yes, so this is the requirements for decent living standards is a global average. But there's no, until now, no regional representation of that. This is another limitation. That's true. However, it's also very hard to model that. Yeah.
But those are the realities of local people. Those are the realities of local people that don't get into your models. And then, sometimes we are asked to follow the developed countries, and those models sometimes don't apply to those situations.
Pierre Enberg, consultant, member of the scientific board of this Congress. If we trespass all the planet boundaries, it means that we have to reduce our consumption and recycle more. It can also mean that we are in overpopulation. So I think we should pledge for reduction of population. What do you think about that?
So yeah, I can make it real quick. So when it comes to staying within the planetary boundaries, it's a question of magnitudes of impacts. So reducing the population with like 10%, or the like from 8 billion to 10 billion doesn't make so much of a difference, because it's a question of magnitude of impacts. Yeah.
Can you switch on your microphone?
No, it is on. Yeah. Okay. Topic, yes, is reducing chemical exposure and staying within global boundaries by sustainable and reduced consumption, a win-win argument for sufficiency. Yes, we know all that we are above the planetary boundaries, which define the environmental limits within which human can safely operate. So you showed phosphorus, nitrogen, climate, biodiversity. But there is a paper from 2022 from Person, which included the new entities into the global boundaries. And these new entities include plastics, for example, and the chemical pollution. And also they highlighted that this pollution have crossed planetary boundaries and is of concern for humanity and several ecosystem services. So a main driver for this pollution are our consumption societies. We saw it with the cobalt in the presentation, with high ecological footprints, externalizing production and pollution to the low and middle income countries, and exporting also additionally our plastic waste, for example, from Europe, from Japan, from America to developing countries, but also plastic waste. Pollution today is responsible for 9 million premature deaths a year. This is the highest cause of death overall. And this includes about 1.8 million deaths from toxic chemicals. A second paper here from Cousins et al. They showed that for PFAS, these fluorinated water-soluble chemicals, which are in the mass media the last half years also for us, that 4 of these PFAS are also above global boundary. So when you compare, for example, the live drinking water health advisory of the US EPA, which they have reduced last year, all rainwater of the world is above the health advisory, even in Tibet and the Antarctica. And so America has a quite low health advisory level. So when we use our European Food Safety Agency, then this translates to the Danish limit of 2 nanogram per liter. But also there we are for most rivers in the world above, and also for a range of the rain, we are above the drinking water limit of Denmark. So for those chemicals, it's really shown that we are, for this chemical group, that we are above global boundaries. Another, is ocean plastic, where it's obvious that we are above global boundaries. Yeah. So in, I think 2040, it's forecasted that we have more plastic than fish, and in the oceans, and also after China closed their door for plastic imports for recycling in China, we saw this huge plastic crisis in South Asia, and also this is mainly from us. So overall, let's say the plastic crisis on land is even bigger than the ocean, but it's not so much communicated. Today we have about 350,000 chemicals on the market, including 13,000 chemicals associated with plastic. While these chemicals brought in modern society progress and convenience, we can detect today more than 300 of these industrial chemicals in our blood and in our human milk. Many chemicals are not thoroughly assessed actually for their toxicity, and for those where we have good data, like for example for the PFAS, we see that the concentration we take to us is above tolerable daily intake for a large share of population. And above all, the toxic effect of exposure of chemical mixtures is not really considered in the regulatory, because the regulatory is only looking for individual chemicals. So at the moment, no chemical regulation in the world really assess the real risk. Yeah, and we are already for single chemicals above risk, and for sure for the combined toxicity of these chemicals. So therefore, the reduction and minimizing of exposure of consumer needs, in addition to better regulation, for sure, also awareness and active exposure reduction by sustainable and reduced consumption. This means sufficiency is one part of the solution to protect their own health. We have done for UNEP a report the last 3 years on chemicals in plastic. So there we compiled all chemicals which are associated with plastic, these 13,000, and 3,200 of them are chemicals of concern. We showed in our report, you can download, it's free on the UNEP page, that we have a real contamination of environment, but also humans. And here I just want to show you 2 slides. One is the external cost assessment of endocrine disrupting chemicals by Athena for the United States. They estimate that per year, these external health costs are $340 billion, which is 2.3% of the GDP. So that was for 2016. And many of them are, the blue ones are plastic additives. The red one are persistent organic pollutants. That's my main working area. My main working area is Stockholm Convention and how to reduce POPs globally. Also, when we look to Europe, there is this kind of external cost estimates for endocrine disrupting chemicals. So here, the estimate is 157 billion as a best estimate, which is about 1% of GDP. When we look to what kind of chemicals, it's also big part is plastic additives like phthalates or bisphenols or brominated flame retardants, 35 billion a year. The highest cost is here from pesticides, 120 billion. And when we look to the effects on humans, it's estimated that the largest effect with 132 billion is the neurodevelopmental effect on children and reduction of IQ and ADH. So, and we really see this, that the IQ over the last decades have increased, and for the first time for a few years ago, the Finnish found that the IQ in their measurements are for the first time decreasing after decades. Another one is the smaller one with the 4 billion. This is about sperm quality. But in this calculation for sperm quality, they only calculate the medical treatment for fertility. So here, the cost of not getting a child is not included because they said it cannot be calculated that you don't get a child. Yeah. So this cost might be much, much, much higher. So man's sperm quality in Europe has decreased for about 50% over the past 60 years. Today, we know that there are 29 chemicals or chemical groups relevant for male reproduction. We know them. We know also, let's say, the different effects. And we know other chemicals like PFOS and organophosphorus esters, which also have an effect, but we do not know how they work. I mean, or how they make that the sperm does not work. But what we know is that plasticizers and flame retardant sperms do not function as they should. So in this study of Kortenkamp, and I recommend to look to that paper, he measured nearly 100 men and found that all men are above for these chemicals about the health index of 1. This means it's relevant. And the range of them were 100-fold above. The mean value was 17 times exceeding. So therefore, the reduction of consumption and shifting towards consuming sustainable products can work in tandem to reduce exposure to hazardous chemicals and decrease also the ecological footprint. This includes, and here intensive chemicals is textiles, toys, electronics, also certain building materials, cosmetics, but also food, organic food. So it is, in my opinion, a real win-win-win for personal health, for safety of workers, and for environmental pollution. So this win-win argument for reduction of consumption and personal health benefits, as well as reduction of the pollution footprint, can be, in my opinion, a good education tool for promoting sustainable consumption and sufficiency. I'm also in 2 NGOs since more than 20 years about sufficiency in Germany, and in Austria. And we did not really achieve much. Yeah, one thing is really the government does not care. We heard it this morning. They are not interested in reduction. So therefore, also the pictures in Africa normally will not lead that people in Europe change their behavior. But when they understand that it's their health, so they might change. So therefore, I think that to put this kind of education on exposure in larger, like the Stockholm Convention education or the One Health joint planned action of FAO, WHO. So such frameworks could be utilized for global education on sustainable consumption with a positive emphasis. And like, this is the last slide.
It was the last slide.
No. That's my last slide. I have one. So Sehab said also it's not only the personal consumption, but also for sure we need to look to policy. And there is also, in respect to chemical policy, now the essential use concept, which calls for reduction. And here we have now from the European commission the application of the essential use concept for the phase out of all non-essential and non-essential uses of PFAS. And the same we have here for plastics, and even the industry here has their own new organization on essential plastic coalitions. So I think so that these two sides of the essential use, let's say also from policymaking side, and on the other hand also from our consumer side, which needs a real big education, yes, might be good arguments for more sufficiency, yeah, and a win-win. Yeah, thank you. That's the last thing.
Thank you, Roland. You talked already in your 2 minutes direct question.
Yeah.
Nevertheless, as we are done with the panel, so whatever comes now can be to Roland directly, question on that, but also like to come back to Hauke. Who likes to raise the hand first?
Yeah. Sorry to intervene again. I think there is a simple principle is that everybody is responsible for its emission. If you emit something, you are responsible for that. So a solution could be extended producer responsibility scheme for all the articles containing additives with banned, restricted, controlled, or suspicious substances. What do you think about that?
No, I mean, I'm also a big promoter, of course, of extended producer responsibility. You know, for e-waste, it worked in Europe, but I have not seen now in developing countries that it's working. So Ghana and Nigeria have extended producer responsibility schemes, but it's very difficult to implement, you know, where to put the money and so on. But we will see. I would like to add to the extended producer responsibility, the extended user responsibility. Yeah, because finally it's us, you know, we buy our television, we use it for 10 years. I agree on the extended producer, but I think also we as consumer should have more responsibility, not to take the responsibility from the industry, for sure. Yeah, but and tell our children, you know, I have also 14-year-old and 17-year-old, so to tell them, yeah, what you buy and what you consume, yeah, you are responsible for it. Yeah.
Further questions?
As you say, there's not regulation on the chemicals and so on, and there's some regulation, of course, but not the combined.
Yeah.
Like you just said, consumer responsibility or user responsibility.
But that's rather about the product, right?
Would it be better to have regulation on banning stuff, sort of the REACH approach, or is it more about radical transparency? Or what's the most pragmatic approach? So if you eat a paracetamol, should it say this is bad for your having children?
Yeah. Huh? No.
Say.
Yeah. No. I mean, like you saw with my last slide, I'm very happy now that the European Chemical Agencies take the step and say, no, we cannot regulate one PFAS after another. We have 4,700 PFAS. We will not come to it, so we regulate all. So that's very important. And then to go into negotiation with the industry, which is happening at the moment. But I also completely agree on your labeling that this is a huge problem. Yeah. So I see it with the POPs. So we have a range of POPs which are currently produced. Yeah, but there is only for one, this is hexabromocyclododecan, there was a labeling requirement, yeah, for insulation foam. But today, the biggest pop is chlorinated paraffins. It's basically everywhere where you have PVC, you also have normally chlorinated paraffins. Yeah, but there is absolutely no labeling. So this would bring things really forward if there would be more transparency and more labeling that the consumer can better decide. Yeah, for sure. I mean, there was, yes.
Can we leave it here because
Yeah.
I'm lost. I don't know how many of you are lost in this details already.
Yeah, you said you want to learn something, so it's fine. Yes.
Which also can to Hauken, I would like to start. Really, you are talking about the donut, but you are talking on the other hand about planetary boundaries, not considering the inner circle, the social aspects which are part of the donut. And that brings to what the lady said before. The decent living, what would it mean for people not in our part of the world, but in others? But this is just one question. Further questions either to Roland or to Hauke, please.
I would like to know from Roland, what are the tips for reducing for the personal consumer to avoid these chemicals? Because they're often, as you said, not labeled, and you're not really sure in which products they are like withhold, or what kind of combination of chemicals are in these products. So what would you do as a personal advice or as an education to make consumers aware, to reduce it as much as possible?
Yeah, I mean,
it's a trend. The central theme is sufficiency, if I may say so. You said, well, sufficiency isn't landing with government, so I circumvent it and come through the back door with health issues to achieve the same
For the consumer.
Yeah, but I'm still interested. Sufficiency sooner or later needs to land. Otherwise, you solve the chemical part and don't solve the bigger problem. So, if you have any suggestions how sufficiency can land, given the issues we have right now, then I would very much be interested.
So first question to Hauke, two questions to Roland, please.
So I was modeling the donut in a slightly different way than other studies did that, in the way that the social minimum, the social dimensions are usually modeled with the SDGs, and we modeled it with decent living standards, which is based on Rao and his research. Does that answer the question?
Hardly, but also, what does this model you have mean for people below the below a decent living standard?
So what it essentially means, the results, it's that it's possible for billions of people to raise their living standards without reducing the well-being of other people, and at the same time staying within the planetary boundaries with the technical means that we have. This would be an increase of well-being for billions of people. This level of sufficiency that we studied, yes, that we included in our study.
yeah. So normally this presentation is rather 30 or 60 minutes, and then I have a part on the individual parts where you in your daily life can reduce this exposure. I mean, one was really this total reduction of consumption. Yeah, this means not buying, I don't know how many textiles a year, but rather, yeah, one textile every 2 years. No, I see nodding from the ladies. No, no, but there you can go through all. We have the ecological, the eco label in Europe, yeah, and they are looking for many chemicals that they are not in. Blue Angel, yeah, you have this even, you have it for China, you have it for Japan, yeah. So this mean buying textiles with eco labels, shoes, but also when it's about buildings, yeah, there are also eco labels. Yeah, and of course there are different qualities of eco labels, so you also have to check the eco labels. But there's also a guide, for example, from Greenpeace and other NGOs on eco labels, which are good and which are not so good. So I said this would be, let's say, a good starting point. Then of course you have all these detergents and personal care products. Yeah, reduction of personal care products is one. I stopped using shampoo when I was 17. Yeah, men don't need shampoo. Your skin don't fade if you stop with shampoo. I mean, if you use shampoo, then your skin always have to put more fat. Yeah, so these are, let's say, simple things. And of course, food, organic food. Yeah, at least for these dioxins, PCBs, and so on. It's really meat consumption which bring us those more fat soluble pollutants. With the PFAS, unfortunately, it's also now vegetarian. But if you go organic, you are for sure. And you saw it with Europe with the pesticides. Yeah, you are on the safe side with the pesticide thing. Yeah. So here you can just go through all your consumption and see where you can improve. Yeah. And I think if somebody is doing that, he will really have a considerable lower exposure to chemicals. Yeah.
What's groundwater pollution? You mentioned rainwater and
yes. Yeah. No. Sure. Huh? You have in Switzerland, you have the PFAS you have on the skis, right? So you have in your Alps, you have some of the PFAS really in your precious water which comes down. And in Europe, there was just this February a publication for the PFAS and the contamination, potential contaminated sites, which are 17,000 in Europe. So therefore, I think that over the next years, you will get kind of informed for all of the drinking water reservoirs we have for the different cities. I mean, Sweden did it already 5 years ago. So they looked to all big cities, measured the PFAS, and there where they had high levels, they put measures. So you can put carbon filters, for example. What is interesting, Denmark has put the 2 nanogram per liter. In Germany, now put 20 nanogram per liter. Also, when you derive the tolerable daily intake and you would calculate the drinking water, it would be actually the 2 nanogram per liter. So I see for Germany, for example, that probably some of the drinking water is above the 2 nanogram, and at the moment they see it as too expensive to put the 2 nanogram per liter. Yeah. So I think that you could ask the drinking water provider, and I think that for Germany now or in recent years, everybody should have measured. So it might be possible that you get the information about the contamination. And then, of course, we have private wells. There you need to check. There is this kind of global map, and this global map is published from Le Monde and Guardian and Süddeutsche. So you can really screen down to all the 12,000 contaminated sites and 17,000 potential contaminated sites for PFAS. Yeah, but only now for this PFAS group. Good. And then there was
sufficiency in general, yes.
Sufficiency in general, yes. No, I choose that topic because, let's say, chemical is my working area. But in the Austrian NGO, where I'm a member, they wrote a book in 2000, which was Genuss und Nachhaltigkeit. This means joy and sufficiency. And I think that this would be an important part, that we show how reduction at the same time can bring us benefit. I mean, time benefit, more socializing. I mean, what the lady said, yes, I mean, our societies where we fight, I mean, with the neighbors and so on, to have good communities. I think that when we show the positive thing of reduction and that we have more time and let's say a little bit more warmth in our society, that this could be also one big trigger. Yeah.
2 minutes left. 2 short questions, 2 short answers.
Sorry, one question to you, Hauge, is that we saw that pure sufficiency is not enough. It has to be a very elaborate approach to sufficiency, right? Did you think about, or does your model include regenerative ideas, business models, approaches, or solutions? Or was it just about reducing the negative impact?
Just looking if there's another hand for another question.
I'm not sure what you mean by pure sufficiency. Do you mean like low demand or high demands for sufficiency?
Yeah, like focusing on the reduction of things and not regenerating, for example, biodiversity or land, regenerating land or something like that, but reducing the negative impact, not necessarily adding more positive impact.
Yes, this is true. We didn't look at things, for example, direct air capture, where we absorb the CO2 out of the atmosphere again. We didn't model that because we wanted to be as close as possible to the technology that is deployed today. We also did not consider a restoration of nature. I think it's quite possible then the results be even more optimistic considering that.
That's great. Thanks.
Yes.
Maybe one addition. Last week I saw a film in Arte about using wood as construction material in large scale, but really then take care that these kind of houses then are for centuries. And by this also you would have a positive CO2 reduction, because you are using here the wood then and bring it into the stock of the buildings. So that's also, let's say, a positive way of
ready to the stage.
Yes, so thank you very much for a very positive and encouraging first round of the session. I hope we'll continue that, no pressure though. So next up are 3 members of the EMPA being strong at this conference. So let's welcome Eleonora, Heinz, and Harold with their 3 presentations ranging from sustainability in buildings via material consumption and climate change to mobilizing materials for the energy transition. Making the start, Eleonora, as for the first round, I'll give you a sign with 2 minutes, 1 minute left, and please finish your sentence. And then we also have a few minutes for discussion and all over Q&A for the 3 of you. Thank you very much. And Eleonora, the floor is all yours.
Thank you. I'll do my best. So good afternoon, everyone. I'm Eleonora, scientist from EMPA, and I'm happy to see you here. I'm presenting this work today that has been done together with the colleagues from the University of Cuenca in Ecuador. So to start, I'm a natural scientist. So when I hear talking about sustainable buildings, what I think immediately is green buildings. Like this one you can see here, and this one are the ones that I used to see on my way to the university. Around the globe, there are many examples of these so-called sustainable buildings, and usually their design integrates plants, system for water recirculation, renewable energies. But a question arises, so is this all we need to define a building as sustainable? Indeed, sustainability is not only about making buildings greener and reducing the carbon footprint, but it's also about taking into account the impacts on society and their cultures. So the sustainability of buildings is promoted within the project SILA, and SILA stands for strengthening capacity for energy efficiency in buildings in Latin America. And the core concept of this project is to build optimal constructions for different situations, where situations relate to different environmental, economic, and social conditions and characteristics. So we started developing our model with a case, starting with a case study in Ecuador. So we started considering construction material coming from the local reality of Ecuador. Our approach can be considered inclusive and interdisciplinary because it introduces aspects of different dimensions of sustainability, and it does it from the very beginning, so from the very first step, that is about the selection of the material. And this selection is made through criteria that you can see here on the left side of the slide. On the top, you can see social and cultural criteria, which cover mainly the relevance, the social relevance, so the relevance for the local communities and the heritage of the country, as well as technical and environmental criteria that are based mainly on aspects like the type of use of the material, the regional availability, and so on. So once the material is selected, the data collection starts, and what we have done was to visit workshops and factories to speak directly with the producers, to interview them, try to understand not only the technical and environmental characteristics of the system where they are working in, but also like the social and cultural aspects of their work. And finally, it comes to the overall assessment of sustainability, where we applied life cycle thinking approaches. And so it's to keep in mind that this approach is still a continuous work in progress. And this is mostly due to the complexity of the methodologies, the life cycle thinking methodologies themselves, and also the complexity in finding trade-offs between the different dimensions of sustainability. So here I want to show you a very simple and preliminary example that is about the production of clay bricks in Ecuador, 2 different types On the left side, you can see the so-called ladrillo tocciano, that is also called in English extruded clay bricks, and is usually produced through semi-mechanized techniques. While on the right side, you can see ladrillo panelon, that is also called massive clay bricks, that is generally produced through more traditional techniques. So what I want to show you here is that what can be, let's say, between the two, the best option from the environmental point of view that stays on the lower side of this graph is not necessarily also the better choice for on the social cultural perspective. So this example keeps in consideration only one environmental indicator. This is, let's say, the most famous one, the most known by society, that is the carbon footprint. And for people who are familiar with the life cycle assessment methodology, we know that carbon footprint is just one out of other at least 15 indicators that can be analyzed to assess the environmental sustainability of a product. A similar complexity can be seen also on the social cultural side, where many more indicators than the ones that we have chosen here could be selected. So to conclude, our next steps would be to improve this approach, so to put together the different pieces of the puzzle, and we would like to do it on different levels, so from different perspectives, starting from the inclusion of additional indicators, and one of these would be security and safety, mostly safety. And I want to provide you an example. So in Ecuador, if we think about the province on the coast, there the criminality level is higher compared to the rest of the country. In those regions, bamboo would be the choice for buildings from the environmental perspective, because it's, let's say, it's very abundant there, it's cultivated there, and also has lower inputs compared to other options. The problem is that if you talk to people in Ecuador, people living on the coast, they will tell you, are you crazy? I will never live in a house that is made of bamboo, because this doesn't protect them from shooting. So they would still go for a concrete house, even though from the environmental perspective, concrete might be less sustainable. So another improvement that we would like to make is to better tune the life cycle thinking methodologies in order to better understand how to find trade-offs between the different dimensions of sustainability, and also include other dimensions of sustainability like the economic aspect and the governance one. And the idea would be to provide a toolkit, so some guidelines that can explain how to use this approach. Last but not least, this approach, we developed it with materials in mind at the moment, but we want to upscale it at the building level, because we know that different materials are used in different amounts in the building, so this can shift the results for the overall sustainability. And the more ambitious goal would be to upscale this exercise at community level, where other types of let's say, interaction and different buildings come into play. So with this, I would like to thank you, and a big thank you all from the entire team of EMPA and of the University of Cuenca.
Thank you very much. Perfect timing. So we have 2.5 minutes for quick questions, Q&A. Bigger discussion, questions, save that up for later for the bigger round. Anya, yes.
Thank you so much. What an ambitious project. I wanted to understand, where do you want to land? I mean, I just know the ecological assumption modeling for existing buildings in Germany. And it's, I mean, there are so many different building materials. Are you kind of trying to cover them all? I mean, that would be a job for a lifetime, wouldn't it?
Well, that's a lot of room for projects in the future, no?
That's
if we get the
true.
funding. No, I mean, the idea now is to stay in the scope of Latin America. I mean, at the moment, our range of working was Ecuador, and we covered like a wide range of materials inside of the country. This project, CELA, is about the cooperation between Ecuador, Colombia, Peru, and Mexico. So this would be, let's say, the priority within the project. And then maybe in the future, yes, I mean, if we can get additional fundings, why not? Maybe we can expand at global level and open for collaboration. Eh?
You heard it, guys. EMPA is up for a lifetime of a project. One more very quick question from anyone? Not at this point. So I would have one. Sorry, Eleonora. Who is making the decisions? Who's investing in the building? So who do we need to target in terms of including the social sustainability factors into their decision making? Like when a building is, someone's paying for that, right? Who is that in your context of your project?
Someone is paying for that. You mean like money wise? So who
Yeah,
is
money
going to
wise.
finance
Yeah.
everything? Okay. Well, this specific project comes actually from, let's say the fundings come from Switzerland.
Sorry, not the project, the buildings.
The buildings.
Yeah.
Well, ideally would be the government in the country, I suppose. Actually, I mean, that would be my answer at the moment. But
Okay.
I would say I would need to think it a bit further because we are really at the initial phase. So we started like 1.5 years ago, more or less. So, and you know, the developing approaches and in the end, tuning a bit the goal while you are going forward, it takes a while. But I would say, yeah, would be more like, because who is regulating what you can build and how is the government? So ideally, we would need to convince them.
Okay, thank you, Eleonora. A round of applause, please. So next up is Heinz with material consumption and climate change. Heinz, the floor is all yours.
Thank you very much. Yes, I will present you the nexus between material consumption and climate change in the case of Switzerland. We are now in Switzerland, so you will know a bit more about Switzerland, how we are in that area. We have implemented a project over a period of 8 years, financed from the Swiss government. The project was called MATCH, Material and Energy Resources and Related Environmental Impacts in Switzerland. The aim of the project was that the Ministry of Environment wanted to know what should be the priorities in the future if we want to improve the nexus between material consumption and climate change. Where do we need to act? So the project was looking into in which areas can we reduce material consumption? How can material circles be slowed down, closed or narrowed? And how can the environmental impact of the materials which are used be reduced? The approach was that we started first with the whole construction area. So we looked at the construction in Switzerland, including all the material flows which go into construction, buildings, streets, everything. And of course, the materials on stocks and the materials which go out. Then we did the same for mobility. So everything which moves around in Switzerland, from cars, trains, ships, everything which is moving around was considered the material flow into this stock and of course the outflow. And then we did it for the rest, which is we call production and consumption. And finally, we made a synthesis of all the three and built up a model. The model can be used to simulate and to try different scenarios of future development. We did at first, we did a snapshot on the Swiss socioeconomic metabolism, so the materials of all the three areas combined. We looked at the average consumption per person, so how much does a person in average consume in Switzerland in terms of materials. We looked at it, what is the individual influence and behavior? What can we really influence? We have heard yesterday about 70% can be influenced by your own decision. We came to a completely different result. And then we, of course, looked from the individual to the society. So this is the picture, the material stocks and flow at present, 2018. I'm sorry for that. Of course, it can be actualized also. You see in the middle the consumption, which is 90 million tons per year. And you see also what is coming in from the outside, from outside Switzerland, from inside Switzerland, and then also what is going out and what remains in the stock. So this is the overall picture. Of course, it is composed of different materials which we considered. we distinguished between 18 materials, different materials which are applied. I mean, 18 main materials, of course, we couldn't go into all the materials, but we summarized some of them, of course, like electronics, for example, chemicals, textiles. And then you can see the same picture, more details. I don't know, go into details. If you are interested, you can look at the publication which we did. So what was the major result? So you see 87 million tons per year, differentiated between construction, 71%, mobility, 8%, production and consumption, 20%. So you see already this mobility is rather not that important, and you can imagine that concrete is the main contribution. That is in our stock, the concrete which we have in our buildings, and of course the consumption which is going into the stock and out. And then you will see here we differentiated between different types of buildings, streets, rail, farm buildings, other buildings. Also in the mobility, you can see two-wheelers, passenger cars, transporters, and everything. And you can see on the level of material consumption what is dominant. No, and you see, as I said, concrete is dominant, and food is also very dominant, 10%. You can imagine that our metabolism in Switzerland, we need fuel, no, to survive. If you look at it from a CO2 perspective, from a climate perspective, the picture changes quite dramatically. You can imagine that all what we use for mobility, the fuel which is burned, is causing a lot of CO2 emissions. The same is true for the housing, for the heating, which we need in winter mainly, and of course also the food. So the picture looking at the CO2 changes dramatically. This was one of the first insights, of course, not so surprising, but it shows a little bit the relation between the different areas and between the different subtypes of the areas and between the different materials. Here again, as a summary of what I said before, you see on the left side the domestic material consumption, which is a standardized term, the tons per capacity per year, and it's 10 tons. And you can see that concrete is the major contribution. This is along the materials, and this is along the consumption categories. You can see the building sector is dominating here. Also, the food is quite important. Single-family houses are important. And if you look at the CO2, the picture changes. You can see that fuels are important. About 50% is from energy carriers, food products, and the rest is relatively unimportant. In the sum, of course, it's important as well, but all the other materials are not that important. And then you can see on the right side the attribution to the different consumption categories. What we were looking at is the question, what I said before, how can a single person influence this situation? And it's interesting, we made a distinction between direct responsibility as an individual, so where you can really decide, you can decide how you move, you can decide what you eat, you can decide how you live. Some people can decide that, others not. Switzerland has about 2/3 of the people are living in a rented apartment, and only 1/3 has an own house. Indirect decisions are through politics, through our votations. We have a lot of votations, possibility to give our opinion, and of course, business decisions which are made. But this is indirect, so we cannot really directly influence it. How can we somehow describe the society? We based our research on a study which was done by the ETH on different archetypes of the society. And you can see the most consuming, here you can see the CO2 per capita per year. Most consuming are two-person households around retirement. So 2 people living in a big house still, children have left, and you have a lot of materials in there. Of course, you also have a lot of heating, which is still needed. And on the lower end, you see families very young with babies. Not children yet, babies. And we simplified that. We made 2%, 20% quantiles. We made 5 quantiles, and we were wondering how would it be if all would behave like the 20% best, or how would it be if all would behave like the 20% worst? And the assignation of the responsibilities, the resignation of responsibilities can be seen here. We had to decide, of course, in which of these subcategories you can decide and where decision is given. For example, if you rent a house, you cannot decide on the heating. And then the greenhouse effect per person through consumption at 12 tons per CO2 per year, also differentiated between the different subcategories in construction, mobility, and production and consumption. So what is the result? It's not 70%, it's below 20%. our result is that below 20%, you can really decide on the future of the CO2 emission. The rest is indirectly. We have houses, we have hospitals, we have schools, we have roads, we have a lot of infrastructure which you cannot decide. You still need a road even if you go with a bicycle. So this was really one of the interesting outcomes. And then, of course, this is the basis on to see where do politicians or decision makers in industry have to act to improve that situation. Here the summary, again, I don't go into details because the time is over. One minute, you said. You can find more information in the summary report, which is in German. There are 2 scientific publications which have been published in 21 and 22, I think, which summarize what I have presented now. And there was an article in Die Volkswirtschaft, which is a quite well-known journal in Switzerland, which goes into public administration. Thank you very much for your attention.
Thank you, Harold. We have time for some quick questions and answers. Any questions to Heinz? Yes, please.
Otherwise, people at home don't hear. How did the government react to your report? Did they do anything?
I mean, yeah, not yet. Not yet. What they have as a result is what is more than what we have shown. What I've shown here, they have a model now which they can use to somehow build different scenarios, assuming that mobility will change in the future. Of course, it will change. We go more into electric mobility. The construction material will change, so they can somehow see what would happen if we would change the regulations in construction, for example, and try to change the material more to wood for a certain type of houses. Or you can decide also what would happen if you would change the food behavior, the eating behavior. So this is the basis for their somehow, let's say, preparing of new legislation, new laws, which then would, of course, have to go through the parliament, and in the worst case, even through public voting in Switzerland now. In the best case or in the worst case.
Perks of democracy, right? Thank you. Second question.
Can you please put on the microphone? I don't.
Could you expand on this figure? You said like 20% is the most we can do individually. I had the impression that maybe our consumption was part of probably 50% of our carbon footprint, like the iPhones are all those materials. Can you expand on that?
Yeah, I mean, you would find the details in the figures, in the tables, and in the what I've shown very quickly. I didn't have time to go into details. Of course, as I said before, this building is here. You can use an iPhone here or not if you want, or a computer or not if you want, or you don't have a computer at all. But still, this building is here. It has a heating system. The roads around the building, the whole town is constructed. And the decision to change this is not with you. The decision to change this is with the government, the local government, depending on also on the legislations they have to follow. So this influence is I don't want to demotivate you. Go ahead with your green consumption, but still at the end, most of it is in the hands of the people we elect, and the CEOs of the companies and the industrial associations.
So go vote. I'm sorry we're out of question, but take notes on your questions and we'll take them up later in the discussion session, okay? Thank you very much, Heinz. So next up is Harold with mobilizing materials for the energy transition. Harold, the floor is all yours.
Thank you. So welcome to my presentation. We're taking now a look into the future and take the whole globe into perspective. Well, we all know that the climate crisis is very urgent, but that also means that we have to think of how can we accelerate a transition to a renewable energy system. No? And of course, we need energy for it. So we need energy to build solar panels, wind farms, batteries. And if you just think of where could this energy come from? So energy is a limitation in how fast we can do the change. So if you take today's renewable energy system, today's energy system, we have about 15% renewable already. That can just stay. The rest is a fossil output. But fossil power plants today, they don't run at full speed. So there is some idle capacity which we could potentially use to build the energy. We could use energy to build solar panels, for example, right? So if we try to do this fossil investment, build renewable energy infrastructure, and get the energy returns of the newly built renewable infrastructure, we get an exponential growth of the renewable energy system. And as soon as this is big enough, we could switch off the fossil. Now we can play around with how much we do invest and if we now replace fossil output during the transition or not, or if we grow demand or not. And it turns out that actually energetically, the best we can achieve is to stay within the 1.5 degree target with about 80% probability. It's the best we could achieve. What is also interesting there is that if you add batteries to the system or energy storage in general, just from an energy perspective, this is very costly. So it quickly brings up the cumulative emissions we need for the transition. So it's not considering yet materials, but of course we also need materials for the transition. And this is basically the thinking we're trying to do at the moment, to think how get and from where can we get materials, mobilize the materials to build up the stocks we need. And we can think of it conceptually as if we had a pipe, and the pipe has a valve, and the size of this valve determines how much materials can flow into filling the renewable energy stocks as materials, right? And the size of the valve is determined by the energy available to mobilize the materials. And a society, which is all the business models, which is all the regulations, which is the governments, the acceptance of people, this is the hands on the valve. It's basically opening or closing this potential to a greater or lesser extent, right? And now, if we put this a bit into a more material flow perspective, you have here a material flow system as we have it today. So we take primary resources from the ground or from nature, make materials out of it and put it in use in society. So we build our in-use stocks, which are still growing today. Parts of the outflows are recycled, but we all know the recycling rate is very little. And the rest is accumulated as losses, either emissions into the air or water or somewhere, or landfills or other abandoned sites. And now we need to build renewable energy stocks, and this stock need to grow fast, otherwise we can't meet climate targets. And this is in a considerable size for most of the materials we need for the energy transition. We could either think of increasing primary production, but if you do it too fast and not in a thought through manner, we have seen yesterday with the cobalt example what could happen, right? And this is also determined about the source stock here. So how much, what is the quality of the source stock we could tap into, right? But you could also think of diverting existing primary production. So how could we do that? Basically reducing the consumption of society. So what we need to maintain our stocks, this is basically the ideas of sufficiency. It's basically for freeing up industrial capacity to build renewable energy stocks, right? Also increasing the circularity. Or we could think of repurposing in-use stocks we have already in society. That is most notably the stocks related to fossil energies. So we have a lot of infrastructure already built. Some of it becomes obsolete because we no longer need that. And we could use these materials to build renewable energy stocks. For example, we have a fossil power plant which has a lot of steel. We could use the steel for building pylons for wind turbines or mounting rails for solar PV systems. And finally, we can also think of remining our accumulated losses, so either emissions or landfills or tailings or something like this. And this has the added benefit also that we redeem some of the environmental damage we have done in the past. But of course, when you have a look at this picture here, the materials which are available in this space may not be the materials we need today to build renewable energy technologies. So we need to also think of substituting some of these materials with materials which are easier to mobilize. And the dynamics of this mobilization will be critical. And we have here this feedback loop of the energy which comes out from renewable energy and from the fossil energy, which has to also be invested into all of these different mobilization routes. And depending on how much energy is available, we can do the transition quicker or not so quick. And what we need to basically research about, and I want to give this thought to you, what we all have to think about is how these different dynamics of these different routes of mobilization play into making a transition. So also there are some effects. How do they influence each other? How much time do we need to build new mines, for example, or at what time does fossil stock become obsolete, or how much can we actually save materials by reducing our consumption down here? And with this, I'm open to questions. Thank you.
Thank you very much. Any questions? Yes, please.
Yes, definitely. I've got questions. My name is Mars Vester, by the way. Have you got any numbers and scenarios around this? This is conceptual picture, but now it's getting interesting, of course.
Of course, this is the first step, yeah, to think of it in a conceptual way, and we have so the energy things we modeled already, but with constant energy investments. So basically, the energy you need to build one solar panel stays constant or declines, right? With learning rates. The interesting thing would be now to know how much more, how does the energy demand for building, let's say, a solar panel changes with the mobilization of materials. So basically, if you have here lower quality ore, you need to mine. Yeah, you need more energy for this route. But if you could maybe repurpose secondary steel, you need less energy than you have to make it from primary source. So basically, this changes very dynamically in the system, and this is the big question. And we're starting to work on this. And if you have any ideas, we can certainly talk about it.
I definitely have. Thank you very much.
Yes, please.
The presenter before said 2/3 of the population is in rented buildings. So that means the uptake for renewable energy, is it very high? Because if I live in a rented place, I will not put the panels, on the place. It should be the owners. Are the owners pushing for renewable energy on these rented properties? And I also wanted to ask one other question. Those people living in rent, do they desire to have a home? And if so, what's holding them back?
Okay, thank you for that question. Before we take that question, we'll keep it in mind. Are there any further questions to our presentation we just saw to Harold? Otherwise, we'll open the floor for the overall panel discussion. Thank you. Yes, please.
Hi, yeah, cool. Is it gonna be like system dynamics or a bit more like, let's say, anchored in real world, like real data, or more like system dynamics stuff, modeling?
I mean, it's the modeling can be done in system dynamics. It can also be done in dynamic MFA modeling or something like this. System dynamics is not cannot be based on real data. So it's, of course, you can do system dynamics with real data.
Okay, thank you. Again, big round of applause to all of our presenters at that point. Thank you very much. If you will click one slide further and another one, time for Q&A. So now is the time to ask the real difficult questions to our presenters from EMPA. So questions are open to all three presenters, and we already got the first one. So please, Heinz, would you be willing to give an answer?
Thank you very much. I'm not sure if I completely got the question, because I was a bit surprised that it was addressed to me. You were looking at me and I was surprised that it was addressed to me. I thought it was addressed to Harald. So can you please repeat quickly, briefly the question again, please?
I wanted to know, with 2/3 of the population living in rent, what are the conditions holding them back from owning a house? And that would relate to the presenters, the uptake in renewable energy. Correct?
Yes, thank you. Of course, you know, Switzerland is an expensive country, and owning a house is not so easy for most of the people. Prices have gone up in the recent years dramatically, especially in town areas like Geneva and Zurich area. So people are really living on rent because there's no possibility. Even rent is very expensive in these cities which I mentioned. So they cannot freely decide. They have not the possibility to decide. If both parents, young family, both are working, then it's possible after some years to have a house and then to decide also on the heating system, energy system. But usually this is very much reused. What is possible now is these balcony power plants, which people can construct. Okay, they can buy in different shops. You can buy solar panels too, and then use them on your balcony if you have a balcony. It doesn't even need a permit. You just have to inform the energy company up to a certain level of performance.
I had a short question on the percentage of the consumer influences on the carbon footprint. So in your study, you reported that around 20% of the carbon footprint can be influenced by individual decisions. And I'm wondering, with the number we heard yesterday, how does your study compare to other studies? Your scope was on Switzerland, if I remember correctly. Is it a geographical thing? Is it a methodological thing? Yeah, I was wondering on.
I don't know how the 70% came. I don't know how it was calculated. Maybe somebody knows better how this study of yesterday or this number came. And in our case, of course, it's based on real data. It's statistical data which we got from different from statistical office. We have different data. We didn't create our own database. We got the database from existing data.
Yeah, just to add on that, I did a study in the last millennium on this question, and it was definitely, the rumor was there with the 70%, and we also came up with it's definitely below 30. Mm-hmm. So it's not only in Switzerland.
Okay. Wow, a lot of questions in the rooms. So 1, 2, and 3. Why don't we collect the questions? So please pose your questions. You guys hopefully pay attention and we answer them en bloc, if that's okay with you, right? Okay, a little brain work for the afternoon. Yes, please.
Statistics doesn't allow to look deeper into gross big spectral formation, so that's very valuable. And regarding this reduction potential, when I read this a couple of years ago, or I don't know when it was published, I was also wondering, because you take the best 20% and the worst 20%. So I guess maybe this also means that like the people really living sustainably, like really making a difference and reducing their carbon footprint a lot, or just like 5%. So if you compare between the best and the worst, so probably you would, I mean, if you don't lie, if you don't drive a car, if you don't consume animal products, if you use sufficient energy in your life, I'm pretty sure we can get well below. But I guess what this study and other studies by Zeta, Zurich, Hochschule for Technical Sciences also shows what you can ask of, like, the average person isn't that much, and I certainly applaud your conclusion, and it's important to have framework, political framework conditions. But I guess it can also confuse, and it starts questioning. I guess everybody should know you can reduce more than 20% if you really address the high behaviors. So reduce fossil fuel consumption of private cars, no planes, no, and what we hear is that's just an opinion, and maybe, yeah, this discussion should be added to this discussion.
Thank you for that comment. Question number 2.
Yes, same question to Hans. I know personal cases of people emitting 2 tons and 3 tons CO2 per year per person, families. So shouldn't we distinguish? It's a question of method. Shouldn't we distinguish between past emissions that are in the infrastructures, that are in the stock, and the present emissions that people emit and that personal and collective behavior can influence? if I understand well, you have used annual consumption of the country divided by the population of the country, but personal choice is different. What about if your new housing is in wood, for instance, rather than concrete? You change your personal balance. So, or did I miss something in the method? Thank you.
Okay, thanks. Question noted. Okay, wonderful. And number 3 was you. Yes, thank you.
Hello, my name is Ole van Allen. I'm from the University of Applied Science in Norway, and my question is to you, Harald. I'm working with Harald Sverdrup. I don't know if you know him, but we work on similar topics that you work on, and we model in system dynamics. So if you want, like, to talk about it, help or whatever, we can talk about it later. And another thing, a comment or a question to your concept is like, do you plan to do it on a global basis, or do you plan to disaggregate in countries? Did you thought about the methodology that you want to apply? What kind of data sets do you plan to use?
Thank you very much. Okay, so I guess, Heinz, you want to start answering the questions?
Yes, thank you. Yes, of course, we can discuss a lot about this 17, 20 or 30%. What we took as a basis was a study which was done 1 year ago, 1 year before we did our research, which distinguished between the actual use of people, not the future use, which potentially is possible if they do even behave more environmentally sound. So we took this data, which was the only data we could use. It was also from Switzerland, so it was applicable. So we took this data, which was very detailed in a lot of archetypes, and I think about 50 archetypes. And when we took the 20 best and the 20 worst, but of course there is still potential on top of that. But I think the message remains the same. The message is that your personal consumption is extremely important, of course, but it cannot save the world with that. We need good politicians. We need decisions which change our whole metabolism, and even that is not possible by tomorrow. A construction is a stock is very long. It's very long in the stock. No, food is very quickly. Food you can change very quickly. Mobility also rather quickly, but in many areas you're stuck to the situation which you have right now. I don't know if this is more or less giving you, but we can discuss bilaterally afterwards if you want.
Okay, thank you. And then I guess, Harald, you can react.
Yeah, thank you for the offer. I don't know the other Harald yet personally, so but
He's here as well.
Yeah.
I mean, I don't know. He was like peeking in the room, but he had a presentation in the other session as well.
yeah, we can chat later. And regarding yeah, it's easier to do it on a global level because you don't have to allocate, and the supply chains are anyway global. So it's doesn't really make so much sense to break it down to one individual country because you still have to have all the links to all the other countries, which makes the modeling just much more difficult or much more complex. But maybe that's something. My goal is now actually to find out, and I'm open to suggestions, and we can talk about it. But is to find out how can we model this new dynamics in the system when we are thinking of being physically constrained by the availability of materials in the feedback with the energy loop. And this is something, yeah. The fundamental dynamics and the mechanics of this interactions is, at least to my knowledge, not very well explored yet.
Thank you very much. We still have some more minutes for more questions. If there aren't any from the audience yet, I would have one question. Oh, sorry, Sylvia, of course.
I don't have a question. I just like to add on these results. Obviously, it's difficult to let go that the consumers have so much influence. But also the old footprint calculators from, I think it was WWF, if you give in the same consumption habits for Germany or in the German country frame, or if you click on Turkey, or if you click on another country, you see the difference. So even if the behavior is the same, your environmental footprint depends on the country you are living in. So it's not new insights, it's not only better data.
Okay, then I would like to ask a question because I really liked your social sustainability criteria. And I was wondering if, I mean, you're all part of the same organization at least, if this idea of the social trade-offs, I'll call it, or you call it that way, finds its place within, for example, modelings for renewable energies, material extraction, material use. Are there any future endeavors to include these kinds of criteria, to not just respect the environmental side of things?
Well, on my side, I think I already showed that the idea is to go not only for these green solutions, but also to take into account the social and cultural aspects. Because, I mean, we have real examples that where the social part really makes a difference in this specific case of choosing materials for construction. But maybe they can speak better about their case.
I think it would be good to ask our head of lab, Patrick Wäger. Luckily, he's here.
Yes, luckily. Yeah, what shall I say? So no, we have different perspectives actually on what social is, and you have seen with the presentation of Hauke, this is another perspective also if you look at the donut economy. So I think it's important to have these different perspectives, and yeah, and in part, of course, or very often, this is some kind of a bottom-up also thing. So you have project opportunities. You're not doing it alone. You are in Horizon Europe project and so on. And then it also happens in a certain way. So it's certainly so. We are called Technology and Society Lab. And of course, we have a societal perspective. But this is not only about just, I would say, doing assessments then with social criteria. So there are other links. Like, for example, what we are doing is what we had this morning. We presented the post-fossil cities simulation game, which is there basically to involve stakeholders in the transformation to a post-fossil city. It's a game, a role play, which from my perspective is also a very social perspective, basically on the kind of questions we are addressing. Yeah.
Thank you for these insights into all of your works. I guess my next question would then be to the Swiss government, whether you want to include the social sustainability criteria, but we can take that up another time. But thanks for being here to all of you. Before we conclude this session, first of all, one last big round of applause to all of our presenters from today.